Hey everyone, so in today's video I'm going to be talking a little bit about upstream and downstream and all that stuff because I think it's been confusing for a lot of people, and it definitely is confusing when you first learn it. So I'm going to go through sort of one example that we saw in class and sort of describe like how you would step by step like reason out where's upstream and where's downstream. So I'm just going to start with like generally like the definitions just so we get that clear. So I'm just going to draw sort of an idea of what DNA would look like. So I'll draw, this is going to be my gene. And so, right, these are like complementary strands because we have double-stranded DNA. So it's just going to be the same on the other side. And then I'm going to draw my promoter and my terminator. Great. Okay, so one thing that we learned about how RNA polymerase works is that it always reads in the 3' to 5' direction, and it always reads promoter to terminator. So you have two criteria, right? You have one, it reads 3 to 5', and two, it reads promoter to terminator. So basically you have to find the strand where those two things line up, right? So like for example, it wouldn't be the second strand because although if I move promoter to terminator, I'm also moving 5' to 3', which is wrong, right? Because we need both of the two criteria to be like satisfied in this case. So if I pick the top strand and I move from promoter to terminator, I'm also moving 3' to 5'. So that's correct. So we found the actual strand that polymerase will bind to, and then, well, maybe not bind, but like interact with and then like transcribe. So we know that it's going to be the top strand. Okay, great. So I'm just going to draw a little arrow so we know it's going to go there. Okay, so now what we say is that the direction that RNA polymerase is moving in is downstream. It's moving downstream towards the terminator. And really that's like the same idea as like if you have a river and you have, oh my gosh, okay, a bunch of fish in the river, right? And they're moving that way. That's downstream. Like the river, the stream that's downstream. But if the fish, like if some fish just, oh my goodness, if some fish just happened to start moving that way, it's going to be a lot harder for him or for her to start swimming in that direction because they're swimming upstream. They're swimming against the current. So really it's the same idea here in the sense that the RNA polymerase will go in the 3' to 5' direction. It's going promoter to terminator. So like that's its natural flow. That's the direction it goes in to read the template. And so anything in that direction, it's heading downstream. But anything behind it or like that it's past is now upstream. So like we can think of in this situation, everything kind of like here and up is upstream, and then sort of like basically from here down would include like all the downstream stuff. And really this is relative to the gene, so like there isn't like an exact location, like I'm drawing it here, but really it's not like a precise location. It's sort of relative to where the gene is located. So yeah, so hopefully that sort of clears up any confusion. So now I'm going to explain sort of the thinking for one of the examples that we saw in class. Okay, so I'm going to draw this quite long so that it's more clear. Okay, and then we had it this way. And then we had gene 1. Gene 2, and I'll draw the terminators in red because it's like red for stop. So this is T2. And then over here we had T1. And then I'll draw the promoters in green for go, P1 and P2. Clear. Okay, great. Okay, so let's just look at gene 1. So we're focusing on gene 1. Let's sort of ignore that gene 2 is there. So the two things that we need to determine which strand RNA polymerase is going to interact with is we want it to find the 3' to 5' strand and that it's reading promoter to terminator. Okay, so let's say it bound to the bottom strand. So it would go from there to there. So that means that it would move 5' to 3', right? Because the strand is 5' to 3', which is not what we want, right? It doesn't satisfy the two criteria. So we know it has to interact with the top strand. So that's the strand it's going to read. So let's do yellow. So it's going to here interact with the promoter and move that way. So everything like there is downstream and there is upstream, right? For gene 1. So if I asked you, where's gene 2 relative to gene 1? Or like if I were gene 1, how do I see gene 2, right? Is it upstream of me or is it downstream of me? So in this case, you would say it's upstream, right? Because we just said it's going to move this way. So everything sort of behind it, behind gene 1, so everything that way is upstream, right? That's what we said. So gene 2, so I'll write this out. So gene 2 is upstream relative to gene 1. Great. Okay. Okay, so now I'm going to sort of change perspective and we're going to look at gene 2. So gene 2, you want to find the strand where RNA polymerase would move 3' to 5' and promoter to terminator. So that would be, in this case, the bottom strand, right? It would move this way because it wants to go promoter to terminator, right? And also 3' to 5'. Okay, so great. So we found the strand, right? This is the template strand for gene 2, right? Gene 2 only, because before we were saying that the RNA polymerase for gene 1 would actually read the top strand. So this is the template strand for gene 1. Okay. Okay, great. So now we found what direction RNA polymerase is going to move in, which means that everything sort of this way is upstream and this way is downstream. Okay, well, that's easy, right? Because now we've literally like drawn that anything kind of past this point and like this way is upstream. And that's exactly where gene 1 is, right? Relative to gene 2. If I'm standing at gene 2, gene 1 is upstream of me because RNA polymerase wants to go this way. So exactly like upstream of that, we would find gene 2. Basically, if RNA polymerase moved in the wrong direction or upstream, right? Like with the fish analogy, it's a lot harder for it to move upstream. It wants to move downstream. And so here we see the same thing. RNA polymerase has those two criteria to be moving downstream. And so we say that the convention is that the direction it moves in is downstream because that should be the direction it wants to move in. And so anything sort of like behind that is upstream. And so gene 1 is upstream relative to gene 2. Great. Okay. So hopefully that sort of clears up the confusion around this and it illustrates sort of the thinking that you would have to do in order to kind of create a picture of where the genes are located relative to each other.